So you see my screen, right? And then okay. So this week's challenge is actually very much follows what you have been doing the last week. And you're kind of creating the next version of, like, so one part is the intent, like you want to create, as you evolve a system, you want to start from intent, and you're basically creating in the week one, you're basically updating such that your intents are captured, and basically the whole point of what is in the brain of the person who's developing it, and it can be just one person or a team, their intents are captured and versioned such that at any time it becomes much more easier for the tracking, security, anything you can think of. Because, and also as you evolve every time, that's the most other important part of week one, was you inject the right context. With once you establish really, really well defined software development cycle, and that intents are captured, then when intents are evolved, the previous intents are provided to the AI, and the AI basically is able to, kind of create that continuity. So it's not just thinking every time a new intent. It knows exactly what it was taught, how it was taught, and because it knows, what was the thinking before, when it updates, it will be very careful, and it's also because of the scope with each intent, means that it will always know, it will have almost always like a full vision, a bigger perspective of what one intent differs from another intent. A simple change of a syntax is very different from like an actual change of an intent, let's say, from using one type of doing one type of way to another. So that is really much captured. And then not only capture is one part, which is logging and monitoring, but the other most important part is actually injecting that as part of the context, so that they always will have that continuity, just like the mind of the person or the mind of the team that's developing is injected. And that's really why it's so useful. And doing it is, of course, it takes time, but you have attempted it. We have seen really amazing work that comes out. The next aspect is really what evolves as, like, when you are doing that, and when you assume that you are doing that, what happens, the evaluator. So is it achieved? Like, is the intent, well achieved? And is the AI has actually developed it well? And that part is kind of coming into governance aspect of it, or evaluation aspect of it, right? So now, in this case, you're going to be learning two things. One is, of course, you're developing an agent yourself using LangGraph and like swarms. And to be able, by swarms, it's in this particular case, we are actually saying that you have a dedicated sub-agents that actually do and contribute. And so this is kind of really a natural continuation of that, the root code is kind of helping you in that case, but it doesn't have, of course, the root code doesn't have also the evaluation and the grader. And that part, you have seen it, something very similar, with probably something closer to this would have been the code rabbit that you have seen. It's kind of an evaluation. It looks, I'm not sure how much you can actually contextualize, and if you are able to actually provide the code rabbit with a certain rubric, I'm not sure. But if you look at that code also, for sure they have done something similar. They have defined some form of matrix and things like that, and then all the time, then when they look, their agent actually looks, and then following some kind of guideline. If you are interested, you can look actually if it's the source code of also that, and you will probably learn something very similar to what we are doing. So this is more of like that from generation to governance. And the automation aspect, that quality assurance swarms, so this is automated auditor swarms, they are deep multi-agent systems. That means they can actually look, depending on, whenever we say deep agents, it means they can take, given a task, they can stay long. And if the code is, for example, really large, with just one instruction, they can actually continue as long as you have the compute resource and the token resource. In our case, it's kind of, we want to learn both how to develop those agents using LangGraph, as well as, architect them from scratch, as well as also just solve one important problem. So it's a two-prong kind of target. One is for you to understand how to design and build agents. But that itself, given that you're not really the one who's doing most of the work, AI is doing, your part is more of architecture and understanding, and a lot of it is, that. But the other really aspect that you have to, the actual important element is you must understand what you're doing, why you are evaluating, whether the evaluation is actually correct. The business value of the challenge is more important, okay? So, and the way that I am thinking, and the way also some part of 10x is doing some of this evaluation, is somehow we have evolved from a normal just using function calls to, like, in our even coding to, but a lot more of them, they were more less agents, but they were more, let's say, the pre-agents, they are function calls. And just basically the LLM was asked to really just answer things based on a full context, to the current method, which is a lot more like very similar to what's designed here. And that means so the kind of, for your mental picture and mindset, think of this one as, what is in the courtroom, what's going on. So when a crime happens, or, anything happens, and what happens is that there's going to be a forensic analysis to identify, to make sure that, this is really serious, that there can be so many things that looks alike, that maybe that a given person might be suspected, but they are maybe innocent. And a given person, they may be suspect, could just look like innocent, but they're actually the suspect, right? So that forensic analysis is one really important element in identifying and in capturing, the forensics people. They don't really care. They really care only about identifying, solving the case, the problem, and really tying to with all the evidences that are out there, making all the connections. They're not interested about whether something is right or wrong. So they are, because if that is, so they have a very clear goal in the forensic sense to identify, like, to basically given an objective. So they have a crime now in a crime scene, and they want to collect every element of evidence and put it in a certain chronological order, in a certain evidence order, such that any other person, let's say a judge, could actually use it and judge it. And then there is, in the courtroom, there's also the bench, which is basically that it's not just one people and one person that's actually doing it. There are multiple people with different, in the US system, for example, you have, about 6 of them to be able to really look at it, and they can be Democrats or Republicans and stuff like that. In the Ethiopian system, the same. Actually in the US system as well, I'm not sure of the Ethiopian system, actually any individual, even a person that has nothing got to do with law, doesn't have, just only being a person, will sit as in the bench to actually be able to listen something and contribute. So that part is kind of it's called dialectical. It's to try to really find multiple views of the same thing. Now, evidences has been collected, evidences are heard, presented, then by the defense team and by the prosecutors as well. And then these kind of the bench, they basically take all that evidence and kind of put together and make a statement, right? So everybody they're like, okay, I think this is the case. I think, some people will look at it from a humanity perspective. Some people would look at it more from this angle, that angle. And then basically the final judge will put together all of them and gives the judgment, right? So that is very similar if we look at it, if we are evaluating some work. We want some independent agents to really look evidences, and then we want independent personas to look at those evidences according to certain personas, and then we want to collect all of them and construct that part. So this, when you look at it, it kind of can act like min-max optimization. In min-max, if you have seen, you know, the movie by I think it's Beautiful Mind. It's again, you know, that same or if you have heard about like the prison dilemma and things like that, that is these are solutions that don't have an actual minimum or maximum. It's the balance. So in that balance, it means like the different judges are trying to are contributing such that they create a balance, right? So basically you will build your architecture, and you will, I think in this case, what you're going to be evaluating is your peers' work. So you are developing, and your peer is also developing, and then you basically analyze your peers' repository based on the incomplete work. Of course, you are developing it, and that would give two things. It would, if if your analysis is great, then you actually provide your friend a very good feedback, which means the person, your friend, will then improve their code. But if your code is actually not complete, which is what we expect as you develop it, then your analysis and your actual grading will be weak. And then you will learn, your friend will tell you like, okay, no, that's not good. Like you didn't actually catch any problem. So it's between you and your friend that you are evaluating, because your friend is also evaluating yours. What happens is that you're actually getting that min-max type of meta game problem. Okay, so we'll kind of in the Q&A we can actually explain if something is confusing. But this is just more like, let's go directly to the actual problem that you are solving. So your mission is basically you're building a digital courtroom, and the inputs will be a GitHub repository URL and then a PDF report. And in the process, so basically you're building an agent that takes basically those two inputs and then applies and basically ultimately creates like a judgment, whether according to certain rubrics that is attached below. It will just say like, okay, your code actually is missing this, your report is missing that, just as the way that we are doing with 10x Grader. But in this case, you are building that. Okay. So, and then ultimately, then after all of that collection and stuff, then you create an audit report that you will send, and that audit report is just a markdown, on your own code. And if it is a code rabbit, that audit report is basically then attached in as part of your PR, or as part of basically before you commit, you get that report so that you can actually improve. Okay, so that's really the mission. This is the most basically the entire goal. And you can really think of this problem to apply in a number of contexts. Of course, the first one is just creating a homework is one, but this is just not only for that. It can be a blueprint for automated security edits, compliance, governance, architecture review, and a lot of things, as we just said, the PR review as well. If you think of CodeRabbit sense, okay. And we might add and expand this section. We gave you a number of also just kind of research and conceptual foundation. So you basically read some things just to understand how LangGraph works, and that some of the research papers are from kind of slightly now in the AI sense old, like 2023. I might update them as we go on. And we also just, if you find interesting other references share in Slack. So, and you have to understand why this matters and why really this type of evaluation is important. Because when you are evaluating, sometimes doing something is much easier. In the absence of, an evaluator, anything is easy. But then evaluation is very hard because you are meta thinking. It's metacognition, which means you actually have to know what is good about, like earlier. So before you build it. So you're actually building like a system that understands quality. And that's usually not an easy task. And it's really almost always, there are many ways that things happen in reality, and you have to take into account that as well. So that's why it's kind of actually evaluation is hard. And when you have a very good evaluator, normally things work really well, right? So it's kind of, in that sense, it's really, really the most important thing you do as well. So the architecture, we, kind of AI gave me this digital courtroom, and I kept it because it sounds nice. But because it's also just like the modeling, the mental picture, it's not, the mental picture kind of works that way. So there are 3 layers. And in the 3 layers, the first layer is the very much like the forensic sub-agents. So they're basically, their role is that they are given, so it's kind of, you can build them as tools, orchestrated, right? So you can build them actually as proper, simple tools, or actually also agents, sub-agents there as well. As you learn the swarm architecture of lang graph, you will know which one, better. So basically the repo investigator. So if like this will be called, this tool will be called. Right now, you might not do all of them, and we gave you, I think down below, we gave you some other places where actually the git cloning, git log, grep, whatever, you can actually get it by just wrapping already an existing tools. But the most important part is that, so the one part is that you have tools within that. If you're thinking of it, this one as a sub agent, which we kind of, that a swarm architecture, that it has sufficient tools to do that. And in principle, you can have just one tool, translate this one actually into one tool, give me like basically the summary of this Git repo. And then you get basically like a report in the format that you expect. And this is one. And so this basically is allowing you to basically, it's not yet doing anything, but it just is, the tools are kind of doing only analyzing and parsing. But the actual repo investigator is given a goal, and it follows that goal. So basically, it has 3 protocols that it is doing. So which means it's trying to apply or collecting evidence, right? So it first is structural. It tries to identify structural evidences. Is there, is there an existence of, so this was, slightly at the last minute, I changed it from analyzing your week 1 to your week 2. So some of them we have to update as we go on. So for example, this sidecar and stuff was from, as you can see, is that from week 1. So we're going to just update what you are actually looking for by this protocol A in terms of structure, what's expected from your week 2 repository. So that's basically what would be defined. But the structure component of it would be looking evidences and collecting evidences about structure. And then the protocol B, the forensic protocol B, will be more on wiring and, whether things are, so again, this from the perspective of last week, whether you had defined selective intent and whether that's actually functionally registered, does package.json and index.ts actually export this function, things like that, right? So this is kind of the wiring aspect of it. As you can see, this is much more of you're building evidences within the repo, within looking at the code. And then the other part is the Git narrative, which is basically analyzing your log history, whether you have been committing and all that. Okay, so this will be updated again to match what's expected for this one. The forensic protocol C doesn't change much, but the 2 others, the wiring and the structure, actually does. Okay, And then the other sub-agent is doc analyst. So this one is kind of taking your text, it's markdown read or cross-reference or PDF. So this basically would read your report, and it has its own protocol, forensic protocol A, which is citation check, and protocol B, concept verification part of it. So within that, it's a sub-agent, but you can probably actually once you parse these docs and you kind of decompose it into text and image, and then the image aspect goes to the vision inspector. That's basically, it has its own protocol A and protocol B as well. One is like analyzing the flow, and the other one is basically the data payload check. Does the XML, is your wiring and your visuals are actually correct or not. So these ones are in layer one. The ones that actually provide you evidence, collect evidence according to, specifically. So there is in the last section, even if you don't follow this, like the protocol A, protocol B, actually I have given a very clear dynamic, like kind of dynamic JSON that you can actually load, and that will actually guide your agents. So it becomes their instruction as well as also their kind of way of judgment. So it's actually, even if this is from the older version, so the latest version is down there for you to use and apply. So that's one. So the layer one is evidence layer, and the layer two is the judicial layer. And this is basically, as I said earlier, you could just have one, right? Then all the evidence collected and you give it to the judge, and the judge just does it. But we want to look, because there are so many ways sometimes that looks the same, and as I said, so we want to actually do it again with another sub-agents that has three persona. One persona is the prosecutor persona, and this is basically the critical lens, and it is actually, as its core philosophy is trust no one, assume vibe coding. But this is basically like the prosecutor almost always, if in an actual court, it's saying the person is guilty. That's it. That's what their goal is. That's their core philosophy is. They're trying to do anything to say that the person is, even if they don't assume innocent, the person is. So it's in the hypothesis sense, their null hypothesis that actually the person is, like basically criminal. In your case, the code is basically bad, or the code is written by vibe coding and has no structure. The person doesn't know it. So that's the one persecutor lens. That's a critical lens, and therefore it screenitizes the evidences for gaps, security flaws, and laziness. And it's basically input is evidence collected by layer one, and then lens is if the rubric asks for surgical mapping and the evidence shows the generic text, then basically the prosecutor argues that, okay, we should give this person one, along this criteria. So that's the aspect that it's basically that criticalness, right? So basically the verdict is a harsh score and a list of specific missing elements. It always is critical. And the defense attorney is actually the optimistic lens. It's almost always saying that, even if the person is very criminal, even if the defense attorney feels they are criminal, but they argue actually no, they haven't done it, or they have done it, unknowingly, things like that. So that's basically, this one is the core philosophies: reward effort and intent. Look for the spirit of the law, which means like look for effort that could really just reward this person. Writing all of this, even generating all of this is not easy. So we should really almost always give them, like the maximum value point possible, right? So again, this is, provides a generous score and highlight the strengths of the submission instead of trying to. And then the take lead, this is the pragmatic lens part. This is basically, they are basically neutral. They don't care about, about the person, their effort, their intent, whether, they don't try to become critical in that sense. They just, the work, has it really delivered the value? Does it actually work? Is it maintainable? So it's actually looking at it from that really work perspective, and it removes the person's aspect of it. And so the verdict is a realistic score, 1, 3, 5, and technical remediation advice. So these basically are going to be the three personas. They then present this persona to the judge, right? So their kind of argument, okay, they work per every criterion, and then they basically assign their value, but this is kind of like the recommended value, while the judge then collects all of them, and basically it would put a judicial opinion, which is basically the final grade, and the final as well advice, and including also just basically so the layer 3, the Supreme Court, basically is rule of, it applies the deliberation protocol, rule of security, rule of evidence, and rule of functionality, and basically it applies the audit report. It does the verdict. It gives, after summing together all of them, it gives the final score, and it then also just provides a summary of the conflict. So, for example, if there's a lot of conflict variance among the things, it just basically that it only just provides a summary. It doesn't try to just, this is the one. I'm selecting one. It's not trying to select one. It's basically making coherence. And according to that coherence and according to its, its protocols, then it basically provides, file level instructions, basically to move from score 3 to 5. So it's basically the feedback it provides, the final report. So given that this is, thing, I will stop here and I will ask if anyone has question, if something is super confusing or clear enough. It's okay if you don't understand fully, but at least you have to understand the idea. Okay. Yeah, Johannes.
Yeah, I'm kind of a bit confused and also worried about the min max thing you mentioned, like the repository evaluating its own. So maybe like clarify a little bit and I can ask my question.
Yeah. So what is like? So as you build it, you're building it, and you have to just check if basically where do you run it? Like, to whom are you then providing that feedback? And how do you know that your implementation actually is useful? So that part is that you are basically evaluating your friend's actual code.
That makes sense after we have built the repo after it's done, but during the implementation we need to have some sort of a test suite, like a repository where we can test our code.
But yeah, is that not the same as actually providing the same thing on the other person's repo?
Sorry?
Is it not the same as, so you're saying a test case, but that test case is just your friend's unfinished work.
So we are going to go like on parallel testing each other, like as we develop it.
Exactly. So I think that it has multiple reasons why I prefer that one. One is that it's kind of collaborative. This thing is slightly complex, and one way just it allows you to collaborate easily with the person. You see their code, you're kind of actually running it. And then also the friend will just really tell you like, okay, you probably can just go take their code and give them some outputs, and they say, no, you are wrong. I mean, I didn't find it useful, because in a way that your evaluation really it's not correct. It didn't collect the right evidence. So, and then you also try to strive, that min-max comes there. You strive to find bugs in them, and they strive to find bugs in your code. Like, basically bugs, both logical bug as well as also, so the logical bug is that you give them comment, they don't accept it because it's not really correct. The physical bug is more like, they're kind of analyzing your code, and they find actually your code doesn't have that structure, doesn't follow, it's not really correct. The way it actually analyzes is not good, or the logic, like basically the code, how it's importing, it's wrong. So they give you both kind of feedback, and you give them both type of feedback. Even if it looks complex, it just allows you to work together and build it and become that. Minimax is almost always any minimax. There is no solution for a minimax problem. It's, if you know about GANs, generative adversarial networks, that really just becomes the what generative AI is. They all start from there, and the reason was that they always start from a noise. So they start from a noise, and then there are two. Basically, the one is the detector, and the other one is the faker. Right. So the faker tries to fake, and the detector tries to detect. And so they start from the noise, and almost always they have to both improve together. So basically, the detector tries to detect that this is noise, this is shit, and the faker says, okay, let me improve just such that the detector doesn't know and rewards me more. And then these things are just, like, so as you build, I want you to build it that way so that you can start still, creating a very simple code base that just actually works. You run it, but it actually doesn't do well. But if your friend doesn't, so you could stop there in principle. But your friend will tell you just like, okay, your analysis is shit. It doesn't work. And that means they detected that your code, the one that's a simpler code you write, is not complete. Now you improve, and then you detect, you run again on their code, and then you give them. So it's kind of allows that, collaborative development. So let's try it. And I know that sometimes when we try something new, as I say it all the time, I don't know the solution, whether this is really too much or not, but I think the point is that it sounds to me, it is exactly how, if I ask you to focus on the actual outcome, not just on the code writing, that is probably the most important value, because your code is providing value. And ultimately, what we want to look is that, did you actually provide valuable feedback from your analysis? And that one you can only confirm if the friend finds it valuable, not when you think that's valuable. Of course, you can give them money and then they can just tell you like, yeah, your feedback is amazing and I love it. But that's it. So does that at least give you an idea?
Yes, it's clear, and it's kind of good experimentation to do. I'm still worried that we still need somehow a universal repo that we can test our code on, so that we can have a consistent, expected, well-known results. We will have results that are passing and failing. If we are testing, like, our friend is code base, let's say it's perfect, our code is not detecting our code is not testing the failing point, it's not detecting the shortcomings. So there should be some sort of, if we could prepare a repo where we will run our tests in addition to the pre-testing thing.
Yeah, I mean, you can generate that principle.
Yeah.
The point is that, for me, I think, yeah, like, I mean, there's, if that's value, I think one can just generate that quickly, right? Just that's the whole point of AI. Of course, it's just a token issue, right? So otherwise, just AI just generate this for me that as a taste, and you can actually taste that before. But the actual reality, in some sense, is more. It's kind of like, even if it has its own complexity, actually is in itself. Your own code can be that, right? So, but yeah, so I think feel free to do so, and I think that's probably good. But in principle, you are going to build it, and we know that you're not going to complete it right away. But if you have now a simple graph, a simple just agent that does stuff, I think then you can start testing and evolve it via min-max type. So the architecture, instead of really just thinking the bigger architecture and build that, just think the intent, like, just the intent evolution is that think something very doable now that addresses this issue, and then develop like and then run it, and then identify the issue and then fix it. And through that min-max type of like with your friends, kind of trying to catch up, their issue, and they try to catch up your issue, evolve and deliberate is kind of the strategy we outline, but feel free otherwise as well.
Awesome. Thank you.
Okay, Mr.
Okay. Yeah. So for the min-max, do we need to show comments proving we improved our agent after a pure audit, or?
Sorry, say it again.
On the min-max concept, do we
Yeah.
need to show the comments proving we improved our agent after pure audit?
To show the evidence. So I think in principle, not like in a way that like, so you mean the GitHub history, right?
Yeah.
Yeah, it has in the part, like in the actually, yeah, like it, so in the evidence collector, like for the repo, it has the forensic protocol, the Git narrative, right? And we have like there is already this Git ingest, and I think you can ask a number of these things if you have some issues. Abdul Hamid, the head tutor, actually knows a lot more of it, so you can ask him and he can help. But the Git ingest can actually give you a more simpler way to just call, and get all the history and stuff. So you can use just packages that does that, and then it just basically synthesizes it as context, right? So ultimately, all of them, the repo investigator, the doc analyst, what it's trying to do is that first, the first part is to create a context. So that means to summarize, whatever it is, like if it's a PDF, put it as markdown and separate images and stuff, and prepare context, right? And then you have the apply on that context, you apply grading. So yeah, I mean, I don't see that complexity, but yeah, so because you're using, you're going to be using like some package that does that. Jakob?
Can you hear me?
Yeah, we can hear you.
Thank you for the presentation. I have two questions. The first one is, are we going to test the repository only specific to this project, or another project, for example, another projects we have done before, can they be tested by this?
Yes. Yeah, they can be tested. So as I said, the original plan was actually to test it on your on your week one project, right? On your week one repository. But then I think Abdul Hamid informed me actually that one, you have done a lot in it, which means then the context window will really grow a lot, because already root code is large and you have edited many files there. And that basically means you would be creating something very complex for the GitHub. And that would really eat your, basically, that amount of tokens. So to minimize your token usage is, if you're creating all of them yourself, then the number of things that you create are smaller. So that's why we kind of are applying it on this one. And the other aspect is also, because you are actively working in it, when you receive feedback, you are able to integrate or say something about it. If it is on an older project or something you don't care, okay, great, and you pass it. But this one is actually, whenever your friend gives you a feedback, you actually implement it. So, and then you collaborate on it. So it's kind of actively on the thing that you do. So it doesn't have then unnecessary cognitive, kind of stress on another project. So everything becomes about this project. Does that make sense? So that's the key idea. Probably we shifted to using the actual this repo. the week to repo.
Okay, it makes sense. And the second question was, is this project related to the week one project, or we're going to start from?
You're going to start new, because this one is going to be, we are asking you to use LangGraph, but everything that you've learned there, their architecture, their everything, you can just bring it and apply it using LangGraph. In principle, you really just, now that you know how Rook agent works and how tools and all that, you can really just design it in similar way. So it's kind of like you're creating an agent. There you were modifying an agent. Here you are creating an agent, but you have already known and understood their agent architecture, how agent works, how tools are called, and everything of that you have already learned from there. And when you come to LangGraph makes it even easier, because it's very simple. It's just basically, because it's a framework, you don't have to write all of it yourself. Just to add a tool, you just add a Python function, or if you're using Node.js or something, then you just add that function. So it's very much, this one is you are creating, and it's much lighter. You're kind of using LangGraph, which is the state of the art actually in terms of agent creation.
Okay, it's clear. And I have to, I just wanted to make sure, I just wanted to suggest something like Johannes said earlier. I think we need some general repository to test our projects besides our friends and people.
So I think, again, I'm hearing this one a few times, but why? Because the thing is, like, you have to know it is the AI that is building it, right? So now the point is, if you want a taste, if you want just a normal taste, you're basically, you're kind of going and building, let's say, unit test, and you ask the AI, just build the UI, unit test for me. Now, the aspect is more like, the way that I'm thinking is, the aspect is, this one is the more important part of it is that it's not generating the report itself, because that one is very easy. Like, you can just go, you don't need even any editor. You can actually go in Gemini or ChatGPT or Cloud, and then ask it to build it, all of it. And then it can actually build sufficient enough that it can be compiled and it works. And when you give it, it can actually output. But the most important value is then whether the output is actually correct, whether it is useful, not correct. It's actually whether it's useful. Now, as I said, if you want to test it, whether it actually, does end-to-end, it works, the code actually works, that one is more of a unit test type. And, I think, yeah, you can basically just have a simple one markdown file, which is like a generated, simulated context for GitHub, simulated context for Doc, and then you can basically use that one as your test. So as basically for your unit test or integration test, you can use that one, generate that one, and apply on it. And so that basically tells you whether your code actually end-to-end works. But that one is one aspect of test, which is called a unit test or integration test. What we are actually trying to test is relevance test, whether this actually provides value. And the only way that I can think of you generate value is if you actually grade someone's work, that actually, who cares about it? So I think both are probably useful. One is more for the usual way of testing your code. I think, as I said, simulate that one. I think we're fine, and absolutely. But the other one, the most important part we want is that whether the outputs there is actually providing real value. That is on your friend's code. Is that clear?
Yes, it's clear now. Thank you.
Okay. Yeah. So I think maybe for the sake of like that thing, maybe if anyone generates one simulation, it could be our side, we will try as well. Maybe just we'll give you one where you can actually test it if that is just for the unit test sets. But that's not that's less for important in terms of value test, whether your code can actually generate value. Yeah, so Abdurrahim, it's true that the current way that it's specified in the challenge document seems to imply the last week project, but we'll update it. You are actually analyzing your this week's one, just for the sake of, because the other one will be too much tokens that you'd have to use. Okay, Rafia.
Yeah, so thank you. I have two questions, both of them on a detective layer. So my first question is, for the detective agents, especially when they're scanning really big repositories with lots of commits in multiple folders, do you have any recommended approaches or best practices for handling that efficiently? Like I'm thinking about things like speeding up the process, or avoiding hitting API limits, or making sure we don't overload the system while we still collecting all the evidences accurately. So do you have any recommended approach?
Yeah, very good question. And I think, probably you can ask, Abdulhamid can answer there. In principle, that's the only the reason why we don't ask you to analyze very big on this particular challenge. But the actual problem is, solving it. You don't solve for a small, you solve for bigger. It's deployed, and actually, you need to think about that. And so one really way is just a background agent, so that basically you don't run it just so you schedule something, and then you basically decompose them, the problem, like a lot more, like what I'm thinking is a lot more parallelly parsing. So the parsing probably becomes an issue. So it's going to be like the context window is going to be limited, and you don't want to add a lot of context in it. But I think over time, I will allow Abdulhamid to say on this. Over time, there is summarization aspect of it as well that went on. There is a kind of if you actually build synthetically the code, the code structure, maybe parsing that and collecting along that is another one. There's a number of actually strategies one can do, and this is exactly what, if you upload also in Google, the Google agents, actually you can learn actually how they look. So there's basically a cursor, or anti-gravity, or Cloud. They all do the same. They just look and parse the code, and some of them use basically a RAG type, and others just basically approach it different. But all of them, they use some form of like AST decomposition. So just maybe, Abdulhamid, do you have any feedback or kind of suggestion?
Okay. So yeah, Yabi has mentioned most of them. Yeah, and like there are multiple ways to do this. So one is searching. So like parser and other agentic IDs do it. There are grep. So grep is one tool in which you can use to find specific tags across multiple files. So basically, it's you already have experience in this. You are using them in the coding agents that you are currently using. For example, in Copilot, it would be in Cursor. It's also in RuCode. And if you want to actually optimize it and remove unnecessary friction, there is also a way to add vector stores, so that the agent could just query the vector store to know where exactly a certain feature exists, and then based on what's returned from the vector store, it will then take a look at the file in which that code actually exists and reads. And I think mostly these issues depends mostly on the agent use. So the agent is not as performant, and it tries to read like every file without using the actual intelligence, saying definitely yes, it will be a problem. But if the agent is good and it knows like the files it needs to read, and I think currently most of the agents are actually, when I say agent, it's basically LLMs with tools. So most of those are currently in a good state. So I would say it depends on the project as well. If it's a huge project, for example, if it was big ones project in which we are going to be implementing this on, then you'd probably see a lot of issues there in regards to tokens as well as to the system. But for this project, since it's not a huge project and you are also building the project as well, you won't be really seeing a lot of issues as long as you use the tools. Like I said, Grape, there's also like reading files, and it won't really be that much of an issue. That's what I'd say.
Yeah,
Okay,
excellent.
thank you.
And almost always try to reverse engineer. You have seen them, you are interacting them, you have seen the root code. From the root code, you have the tools, and just bring those tools as well. You can just change them. And then already also, in even LangGraph and LangChain, you have tools that actually do stuff. So I think it should be easier, like, to implement them fast here. Yeah, you saved 2 questions, and is there another question, Rafael?
Yeah, I do have another question. This one is like addressed correctly. So the second question I have is, so if a detective finds conflicting evidence, like the PDF report says file exists, but repo investigator doesn't find it, how does the agent handle that? I saw that the Chief Justice prioritizes facts over opinions, but in this kind of mismatch, does it just flag the error, or does it try to do something smarter, like reconciling the difference or weighting one source over the other?
Very good question. The evidence collector doesn't. It just presents the evidence. Something is said here, but I didn't find there. And then, so it's kind of basically, it's basically really curating the evidences according to what's specified, the goal. And then those all our evidence are then going to the other 3 persona, the judicial layer, right? The layer 2. And those agents are the ones that are looking, all these agents. Let's say the prosecutor says, as I said, as I thought before, this person really doesn't know anything on this, whatever, and therefore they're lying. So we should really give them on this thing, 1. While the other, like basically the defender part, they would say, no, it's actually demonstrated effort. It may be just a simple mistake, but maybe it has changed the name. We should be looking, and is there any evidence that actually, and if the detector evidence is good enough, I probably have found also something like that. He might add, or like basically that there's no he or she, it might add that. So I think it's kind of the evidence collector, as it gets better and better and better, it tries to really become good detective. Just that would really summarize, such that all, very fair judgment is given. And judicial layer 2 is what is trying to synthesize from all these evidences, and according to their persona, try to put that again. The persona doesn't mean lie. It just basically means it uses only the evidence, and based on the evidence, it reasons. It's a dialectical sense. And then they all argue for a certain point, and then the final judge is what would reconcile. So it's the final judge's role, that's reconciliation and all that. Does that answer your question? Okay.
Yeah, that definitely does answer my question. Thank you so much.
Great. Deraji?
Thank you. I got 2 questions too. I'm wondering that if the variance between judges is large, let's say one judge says 1, the other judge is 5. So what is the exact procedure for deliberation? I mean, should we average scores, or should we implement custom conflict resolution algorithm? So yeah.
Yeah, I mean, I think here it's again, definitely answer. This is something you can learn as well, from just how these things are done in an actual case, but I think this is basically it has all judges have their own protocol to apply. This is what's really written. FR points from defense security flaws capped, so they have kind of, I mean, again, this is written in week 1 sense. So, so in the week 1, but it basically, they say they think security is high. So rule of security means, okay, definitely if there is risk in security, it just caps the score to 3. And evidence, if the defense claims deep thoughts, but repo investigator found no architecture notes, whatever, the defense overruled for hallucination, right? So these are kind of capping this, like providing the Chief Justice some form of rule that allows it to, max the points, as well as also just like conflicts, kind of merge conflicts. So for example, if even if one says 1 and the other one is 5, but the neutral tech lead confirms the architecture is modular and workable, this carries the highest weight for the architectural criteria, right? Because they know what they're doing, so you trust one judge more than the other. So I think these these ones are kind of allows you to just applying the rules.
That's so one last question, please. So how many agents are expected to run in parallel? I mean, and then is there any compute limits like CPU or memory?
I think hopefully you don't, but it's just, let's say so all of the detectors, the detective layer, the layer 1, and the layer 2 can run in parallel as they're collecting. But definitely because layer 2 requires layer 1, so all of them can run in parallel, but layer 2 needs the evidence is complete, so they have to wait. So in parallel, you can think of 3 they will run, and then once they finish, also because these are independent, the 3 also can run in parallel. So at max, you are running 3 in parallel.
Okay.
And the final layer, also the Supreme Court also actually needs all of the other 3 to finish. So in some sense, so these are sequential, by layers are sequential, but within layers it's parallel.
But the issue is that running multiple agents at the same time consumes CPU memory. So
Yeah, I mean,
if I don't manage resources, means I might crash because memory is exhausted.
I think you can run one in sequence, all of them if you want to, as long as you have a flag that says use number of parallel agents 1, and then in that case your code handles for your case. But when you have a good machine, you run it with maximum, so that should be fine.
But when I run sequentially one after the other, I think long chain depends on parallel execution, isn't it? So
no, I mean, you can always say parallel, every long chain, long graph, you can always just run like things that control by variables. So it's your choice, it's your architecture.
clear. Thank you.
That does it.
Am I audible?
Yeah, you are.
Okay. So my question is, I don't see the full document, so I don't have a question on the implementation details. But when you say the min-max implementation in the agent, so my understanding is we build the initial evaluator, then we send it to the another person's evaluator and get feedback, then update our evaluator based on the feedback. So
so it's very much it's not in the agent, it's really exactly in the communication between you and your peer.
Okay, so is it for the evaluation, our work in the agent evaluation, or does the agent need to do that?
So I think in your description, one thing is not correct. You said you send your code. It's more like you run you run your code on your friend's code base, let's say, that you basically the context his or her GitHub context and report context. And you run on that and you give them feedback. What you send them is feedback. They also run on your project, on your code base, and they give you feedback. And you then interact with them saying, you know, no, this feedback was correct. I like it. I implemented it. I used it to improve it. No, that was wrong. You give them feedback on their reports to you. The minimax is that they're trying to catch something, you know, to identify the issues in your code base, and you tell them, no, that was wrong, you know, and that is correct, and that, and you also give them on theirs, and then they do the same.
That communication has to be done within the agent itself.
No, 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 no,
Automatically.
Slack. No, that's just a human-to-human communication. You
Alright,
just
so
you give them reports. So you give them reports, they give you reports, you talk, you know, in the normal. So not everything is agent. So the agent just does the evaluation on. So the Minimax part is a very much human communication. So I want to make it very clear to everyone that Minimax, don't think of it as, you know, I want you to understand how in a normal life Minimax applies. You know, it's not on the agent in this case. The agent is not doing Minimax, or you're not implementing Minimax algorithm and stuff. It's more the way that you are doing it as you talk, as you are evaluating another person and another person evaluates your, that becomes Minimax likes.
Okay, so it was not like
I think we are probably my internet. Yes, exactly. So can you hear me? I think
so.
yeah. Okay.
That means the evaluation of the feedback, whether it is correct or useful, has to be done by our judgment, not by the agent. I want to clarify that.
Yes, exactly.
Okay.
Yeah. So it's the other person exactly gives you judgment, and you know you correct on that. And so that's the aspect. So we will probably hold one session later, really, once you have a chance to go through it, to clarify, because this might take, and also how it's done. So we have in 10x, we assign, everybody is assigned to grade each other, and that way, it doesn't necessarily mean, for example, you would grade the other person and the other person grades you. It might be like you would grade, let's say, a person A, and then person A grades person B. So it's kind of, but you know, and then person C grades yours. So you might, but maybe just yeah. So we'll have a separate session on that, basically clarifying. So I think that there's, yeah, but the part is that the agent is really doing simply evaluation according to, you know, a given JSON that you give it how to evaluate, and it translates that one and then evaluates you know, some code base plus report, and it generates report. That's what it does. The agent is really doing that, and it's doing that according to the kind of the instruction, you know, by collecting evidence, by then kind of looking at that evidence via this 3 persona, and then by finally then kind of putting together. That's very much what the agent does, nothing more. But how you develop it, but throughout the week is more, you know, through collaboration and through kind of this Minimax approach, human to human.
So the building has to be according to the document. That means to evaluate their work, or the evaluation work, how they implement the evaluator, not actually how the GitHub or the code another general purpose GitHub structure.
Exactly. So just really, yeah. So like how they're exactly how they're developing this particular project. Yes. Okay.
I'll finish my question. Thank you.
Great. Abdurrahim?
Yeah. First, I want to say sorry that we are taking too much time on this. So I have a simple question, perhaps. So from my understanding, is this going to be, project agnostic? Meaning we can provide the evaluation rubric and the repository, and it will generate, a judgment based on those inputs.
Yeah, so you mean like for other, it can be applied in any other context as well. Just the only, like the configuration for it will be what we call rubric, or just the kind of a JSON that defines, just like that. This is the kind of the JSON that will define or control, provide some form of control for your agent. What's the actual thing it's trying to evaluate. So, and this is the one that you're going to be using. This is kind of the configuration for your code, and how it evaluates. This is how we will evaluate your final work. So this is just basically to give you an idea how we will evaluate. So again, yeah, so it's unfortunately, the last minute change meant not everything is propagated in the document. So that's why we will hold one session, but basically the idea, and you can start on reading the kind of about LangGraph, start implementing some of them, and we will update exactly the particular. And I think all of it just will not change as much. It's just basically the actual exactly what you are evaluating and stuff will just change. So the changes here will change basically what would be inside of that configuration. And this configuration dictates how your code works, and that your code should work for, if you are now evaluating, next week something else, it should be able, all you have to generate is this. The code structure will not change in any way in that sense. That's, just to give you an idea, our evaluator code doesn't change every time when we create for this, for that, right? We only give it rubric and context. So those are the inputs, and the code should work irrespective of, and then it outputs according to the structure, certain structure. So I think you're doing something similar. Is that clear?
Yeah, that's clear. Yeah, thanks.
Okay, great. So I think then, yeah, because it's a lot of time, and I want so Lul, and then after Lul we'll stop, and then we'll probably have another session where we explain also in more detail, after lunch. So yeah, so just go on, Lul.
So it was a follow-up question on what we are talking. So it's a configuration that we'll be giving our agent. So it will be agnostic of any kind of repo. Basically, it can be any repo, but how
Yes.
it will be using it, it will be basically a configuration. Basically, some kind of, we're going to be creating some configuration.
Yes,
That's
exactly.
my understanding, correct?
Absolutely correct. So this will act like a configuration, and its outputs, so basically here, it probably right now, but the output, the final judge also, I'm not sure if I have put the final judge also, yes, right now it will probably output this, but the final judge probably will output also in a certain format. So the input configuration defines how the evidence collectors, what they're collecting, and how the judges also, the instructor, you can dynamically instruct them, and finally also the final judge, how it outputs. That's it. And then your code should work, whether it is repository X or repository Y. It shouldn't care.
Thank you.
Okay, great. Yep. So I think then let's stop there, unless there's a high burning question. And in the meantime, think, develop, research, and we'll update you. Wonderful.